According to classical physics, the universe is four-dimensional. That is, it consists of four dimensions. Among these, 3 dimensions are spatial or local, and the remaining one is the time dimension. However, according to bosonic string theory, the universe has 26 dimensions. According to string theory, it has 10, and according to M theory, it has 11. Although these theories remain only hypotheses, a beautiful physical presentation of higher dimensions and the time dimension is shown in the movie Interstellar. Now the question arises, if there is any dimension beyond the 3, what are those dimensions like? How can we imagine such dimensions? And what is the arrangement of these higher dimensions? What is a dimension? In answer to this question, I would say that a dimension is movement or change. Imagine a point, a dot. This is zero-dimensional. Although a zero-dimensional point has no length, width, or height, such a tiny entity cannot be physically represented. Therefore, we consider this point to be zero-dimensional. Now imagine another point. When you join these 2 points, you obtain a line, a one-dimensional entity. In a one-dimensional space, any object can only move to the right or left. Now imagine 2 one-dimensional lines and join them as before. Then you obtain a plane, which is 2-dimensional. In this plane, any object can move right, left, forward, or backward. Next, imagine 2 two-dimensional planes and join them in the same manner. Then you obtain 3-dimensional space, a solid or a cube. In this solid, any object can move right, left, forward, backward, upward, or downward. Consider that for a one-dimensional space you need 2 zero-dimensional points. For a two-dimensional space you need 4 one-dimensional lines. And for a three-dimensional space you need 6 two-dimensional planes. Now, what would a 4-dimensional space be like? Many might say that the 4th dimension is time, and that is correct, but here I am considering the time dimension separately. I will discuss this further at the end of the video. You might be wondering how a 4th dimension would be with respect to the special or local dimensions. Now if we join 2 3-dimensional solids as before, we obtain a hypercube. That hypercube, a 4-dimensional object, is in every way analogous to a 3-dimensional cube or solid. On a mobile screen, that hypercube might seem like a regular 3-dimensional object, but in reality it is not. In any cube or similar solid, the faces or borders on all sides never intersect one another. However, in the case of a hypercube, note that the cube-like sections or sides on its faces do intersect with one another. Such an image cannot be properly displayed on a 2-dimensional screen or even in 3-dimensional space, and besides, our brain is only capable of perceiving 3 dimensions. Yet we can form an image of the shadow of a 4-dimensional object. We can project the shadow of any 3-dimensional object onto a 2-dimensional surface, causing that object to lose 1 dimension. Similarly, if we imagine the shadow of a 4-dimensional object, it will lose 1 dimension so that it will appear in 3 dimensions. Imagine a box. The box is a 3-dimensional object. When its shadow is cast onto a 2-dimensional surface, we see a 2-dimensional image. However, if the box is rotated, its shadow will look somewhat different. In fact, its shadow will take on various shapes. Now consider a 4-dimensional hypercube. Its shadow will be 3-dimensional. Just as we have said that the shadow of a 3-dimensional object is 2-dimensional, if a 4-dimensional hypercube is rotated, its 3-dimensional shadow will appear accordingly. Just think about how intricate the shadow of a 4-dimensional object would look in 3 dimensions. Now try to imagine what a 4-dimensional object might be like. A 4-dimensional object, or any object of even higher dimensions, cannot be depicted in this 3-dimensional world. However, mathematically, it is possible to explain 4 dimensions, 5 dimensions, 6 dimensions, and even higher dimensions. Now, suppose that some 4-dimensional object were to appear in our 3-dimensional world. How would we perceive it? For this, Edwin Abbott's book, Flatland, published in 1884, is very useful. It is essentially a mathematical thought experiment. Flatland is a world in which every creature and object is 2-dimensional, that is, they exist solely in a plane. Thus, the inhabitants of Flatland see any creature or object as 1-dimensional from afar, and as 2-dimensional when viewed up close. For instance, in our 3-dimensional world we observe the sun from afar as merely a 2-dimensional disk. However, when seen up close with a telescope, we understand that the sun is three-dimensional. Similarly, the inhabitants of Flatland see all objects as one-dimensional from a distance and two-dimensional when nearby. For them, perceiving a three-dimensional object in its true form is impossible. They can only see it as one-dimensional or two-dimensional. In Flatland, if a Flatlander were to encounter a three-dimensional object, he would only see a single one-dimensional line, indeed only as many lines as are present, and not its complete three-dimensional form. In short, if any creature from the fourth dimension were to enter our world, we would not be able to see its full structure. Our three-dimensional capability limits us to perceiving only three dimensions. In fact, humans can control only three dimensions, that is, one dimension, two dimensions, and three dimensions. Now, regarding time, if we consider time, as revealed by Albert Einstein, as one dimension, then this time dimension is not under human control. Humans can move anywhere in three-dimensional space, right, left, forward, backward, upward, or downward. But if the time dimension were under our control, like the spatial dimensions, we could travel forward or backward in time at will. In other words, we could go to the past or the future. However, that is not possible because the time dimension is unique, flowing only toward the future. In the movie Interstellar, the special fourth dimension and the time dimension are shown as one. In one particular event, the film's main character Cooper finds himself in a situation where the special fourth dimension and the time dimension come under his control. Through this, Cooper appears in his daughter's room and attempts to convey some crucial information to her. However, because Cooper exists in a higher dimension, he is unable to directly communicate with his daughter, Murph. According to string theory, among the fundamental forces of the universe, only gravity can move from one dimension to another. Thus, Cooper transmits the information to his daughter through gravity. Whether extra dimensions actually exist is not certain, but mathematically, extra dimensions are indeed very rich. In fact, mathematically, an infinite number of dimensions can be explained. However, the actual appearance of such higher dimensional objects cannot be imagined by our three-dimensional brain. Among the many causes of environmental pollution, one of the most notorious is plastic, one of the greatest evils and significant problems of our current world. Yet, a possible solution to the plastic problem might be mushrooms. To learn how mushrooms can help resolve the plastic issue, you can watch this video. If you like the video, please subscribe and join the Science Sphere family.